Hi guys, today we're going to take a look at section 7.7, which is solving trig equations. Now, at the very top, you're going to see our normal chart. Okay, I have not filled in the angles yet, and there's a reason for that. I'm going to fill that in a little bit differently here in a second. But first, let me kind of explain what we're going to be doing today. So, now this isn't part of your notes. This is some earlier notes. What we're going to be doing today is we're going to be solving equations. So, for example, let's say I had the sine of x equals 1/2. Okay? Now, this is a sine graph, and this is showing us all the points on a sine graph. Well, when you want to solve an equation, you want all values of x that would work. Okay? So I want every single angle possible where if I take the sine of that angle, I'm going to get 1/2 as an answer. So like this horizontal line right here is at 1/2. So this angle, which should be pi over 6, has a y value of 1/2. But then over here, which should be 5 pi over 6, also has a value of 1/2. So we're not going to be looking at our principal values. We're going to be looking at every single angle that would possibly have that sine value. So I want the angle that's in quadrant 1, and I also want the angle that's in quadrant 2 that has a sine value of 1/2. But remember, sine graphs and cosine graphs and tangent graphs are periodic. They repeat themselves. So over here, there's another angle that's going to have a sine value of 1/2, and then another one and another one and another one. There's a negative angle that has a sine value of 1/2. So today, when we're doing these, we're going to be looking at all possible solutions to this equation. Okay, so that's why I have not filled in my angles right here. I'm going to go ahead and draw in every single angle we're going to be dealing with today. So for example, 0, we know that starts with 0, but also pi has a reference angle of 0 as well. So this could be a solution as well. This is pi over 6, but then I'm going to go ahead and draw in 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now, maybe you don't need all these. Maybe just having the pi over 6 there, you're good enough at doing these, in your head, but I'm going to draw them down so you have them visually. Okay, this is the pi over 4 row, but then this would be 3 pi over 4. This would be 5 pi over 4, and 7 pi over 4. This would be pi over 3. So his counterpart in quadrant 2 would be 2 pi over 3. Then this is 4 pi over 3, 5 pi over 3. And then the last column is pi over 2, but also 3 pi over 2 also has a reference angle of pi over 2. Okay, so that's how I'm going to draw the chart, and that's going to help me solve these equations down here. I'm also going to keep in mind that all students take calculus, because that's going to come up as well. So, for example, if you look at the example 1, it says solve each equation for all values of x. Now, how many values of x are there? Well, there's an infinite number of solutions. So, what we're going to do is, once we have a generic solution for all values, we're then going to write down 6 actual solutions, and we're just going to leave it at that, just to show that, we know how to do that. Okay, so first equation, cosine of x equals 1/2. Well, I'm going to try to get the x by itself, so I'm going to move the cosine to the other side. That's going to be x equals the inverse cosine of positive 1/2. Okay, so I'm keeping in mind that cosine is positive in quadrants 1 and 4. So I'm going to go up to my chart. I'm going to see cosine of 1/2, and I'm going to see pi over 3 and 5 pi over 3. Those are the two angles that give me a cosine value of positive 1/2. So x could equal pi over 3. I'm going to leave a little space here. I'm going to fill this in a second. Or x could equal 5 pi over 3. Both of those are valid answers. Now, the reason I left the space right here is because, remember, because cosine is periodic and every 2 pi multiple from pi over 3, I'm going to run into another angle. And then I'm going to add another 2 pi, and that's going to be another angle, and another, and another. Same with the 5 pi over 3. Every time you add a multiple of 2 pi, you're going to land on another angle that has that exact same cosine value. So these two equations right here, these are all values of x that have a cosine value of 1/2. Now they want us to find 6 actual solutions. Well, I know 2 actual solutions. I know that pi over 3 is a solution, and that every time I add 2 pi to that number, I'll get another one. So remember, this is where I like to think of 2 pi as 6 pi over 3. Think of it with a common denominator, because if I take 1/3 plus 6/3, I'm going to get 7/3. That's another angle that has a cosine value of 1/2. If I take 7/3 plus 6/3, I'm going to get 13/3. That's another. So there's 3 based off this solution. Then I'm going to come over here. I'm going to write down my 5 pi over 3. So there's my 4th answer. And then I'm going to add 6/3 to 5/3 and get 11/3. I'm going to add 6/3 to 11/3 and get 17/3. And there are 6 possible solutions to that equation, and all 6 of those would work. Okay, so that's what we're doing today. So this is all the solutions, and here are 6 actual solutions of the infinite number of solutions that there are. Okay, let's look at example 2. So again, I'm trying to get the x by itself. 3 tangent x equals radical 3. That's the first thing I can do. Then I can divide everything by 3. So the tangent of x equals radical 3 over 3. Then I can move the tangent over. X equals the inverse tangent of radical 3 over 3. And now I'm going to look at my chart. This is a positive ratio. Tangent is positive in quadrants 1 and 3. So I'm going to look at my chart. So here's radical 3 over 3. And pi over 6 and 7 pi over 6 would be the 2 angles that have positive tangent values of radical 3 over 3. So x equals pi over 6. I'm going to leave a space for a second. Don't write anything there. And x equals 7 pi over 6. Now, tangent is also periodic. These answers will repeat forever and ever and ever. But if you remember from much earlier on when we were drawing tangent graphs, tangent has a period of 1 pi. Which means every time you add 1 multiple of pi to both of these angles, you're going to land on another angle that has that same solution. Okay, so again, here are 2 angles. So x equals pi over 6. Now, again, I'm going to think of pi. So this is 1 pi. So I'm going to think of 1 as 6, 6. And that's what I'm going to add to these angles. So 1, 6, and 6, 6. Well, that is 7, 6. So that's the other angle that I had. And now I need 4 more. So I'm just going to keep going. 6, 6, and 7, 6. So 13, 6. Add another. You're going to get 19, 6. 25, 6. And 31, 6. Those are 6 solutions that all have a tangent value of radical 3 over 3. Okay? Now, I want you to try number 3. So pause the video, try number 3, and then play the video, and I'll show you the solution. All right, so here's my solution. So I moved the radical 3 over, it became negative. I divided by 2, I moved the cosine over. Now, negative radical 3 over 2, I am taking the inverse cosine of a negative. So the angle that I'm looking for is going to be an angle that's in quadrants 2 and 3, which is where cosine's negative. You need to think about that every single time you get ready to go to the chart to solve one of these. So the 2 angles, so from the top of my chart, that have a cosine value of radical 3 over 2, but are in those two quadrants, are 5 pi over 6 and 7 pi over 6. So that's my initial solution, 5 pi over 6 and 7 pi over 6. But every time you add 2 pi k to one of these, so I'm thinking of this as 12, 6. That's the magic number. And so I took 5 pi over 6 and added 12, 6 and got the next angle and the next angle. I could have kept going, but the numbers are starting to get big, so I went over to this angle and added 12, 6 and 12, 6 to get my 6 total solutions. Okay? All right, one more. So take a look at this. It's going to start off pretty straightforward. We're going to move the 1 over. Sometimes you can do multiple steps. I'm not going to. So move the 1 over, divide by 2. So negative 1/2. 2 theta equals the inverse sine of negative 1/2. Now, we have not solved for our answer yet. This one uses theta, the other one's used x. It doesn't matter, it's still a variable. Now, I haven't solved yet, but I need to stop what I'm doing. I need to go to my chart, and I need to find the two angles that have a sine value of negative 1/2. So these are going to be in quadrants 3 and 4. If I look at my chart, there's 1/2. There's 3 and 4, so 7, 6, and 11, 6. Those are my solutions. Now, we're not done yet. 2 theta could equal 7 pi over 6 plus multiples of 2 pi. Or 2 theta could equal 11 pi over 6 plus multiples of 2 pi. But we haven't solved for theta yet. So, to get the theta by itself, now we need to divide everything by 2. Okay, so everything. We're going to divide the 2 theta by 2. That'll give us theta. 7 pi over 6 will give us 7 pi over 12. It just doubles your denominator when you divide by 2. Plus, and this will be now pi k, not 2 pi k. Okay, so that's going to change those extra solutions we have. Or theta could equal 11 pi over 12 plus pi k. So these are the first two angles, plus any multiple of pi, which I'm going to think of as 12 twelfths. So theta could be 7 pi over 12 plus 12 twelfths. So that'd be 19. Or 19 and 12 would be 31. I'm going to stop. I'm going to go over and use my other angle, 11 pi over 12. And then 23 twelfths and 35 twelfths. So those are the 6 angles that I could plug into this equation, and everything would solve out and it would equal 0. So take a look at your worksheet, your homework. Try some of these on your own, and let me know through Schoology or Messenger if you have any questions.